This is Annie with the Perceptual Computing Lab. This is the fourth part of a four-part tutorial series on how to get the basic functionality of the Perceptual Computing SDK into the Unity game engine. This section will cover how to get face tracking. Let's go ahead and open up our main controller script. First thing we're going to do is add some more information in the beginning of our script here. So let's throw in private PXCM face analysis, detection, and then data. And let's call it user face. We're going to make a private boolean, and we're going to call it face found. We need two functions that are different from what we would need if we were using the gesture data, and that's going to be a private int, which we're going to call face ID, and then a private oolong, which we're going to call face timestamp. Let's throw in another private float and call it head position X. In our start function, let's make sure that we add the correct data into our initialization, otherwise it won't work. So pxcu pipeline dot mode dot face location, and then just as we initialize the user hand, we want to initialize user face equals new, and then it'll pop up with the right one, which is detection.data. Let's give it a close parentheses. Now let's go down to our update loop. Again, everything needs to be between acquire and release frame, so just above the release frame, let's put if myCamera.query face ID, and then we want to give it an integer for face ID, which can be 0, and it wants an out int face, so we say out face ID, which is the value we passed earlier, and then out timestamp, or face timestamp, which again is that oolong that we made. We don't need to be accessing that necessarily, but the function does need those values in order to run. So once we did that, myCamera.query face location data, and then face ID, out user face, which is our not our GeoNode, but our face detection data object that we created up here. Let's add head pose X equals remap, because again it's going to be in its space, not our space. We want to cast our user face as a float, so we'll put float in parentheses in front of what we're doing, and then call user face, which again is this guy, dot rectangle, which is how we get the square of the around what it's tracking. It's the square around what it's perceiving your head to be, and then we're going to feed it X. Let's throw in comma, and these are just arbitrary values for our remap function that I came up with. You might have to come up with your own. If you missed the original tutorial which went over this, we're feeding it the original data that the camera is seeing, so in this case our face location, and then old minimum is going to be how far to the left you can move before you are out of screen space. Old max is how far to the right before you're out of screen space, and then new minimum is going to be how far left you want to go in your scene view, and new max is how far right you want to go in your scene view. So my values are 428.0f, 17.0f, negative 3.4f, and 3.4f. Oh, the reason it's giving me this is because I should have an extra parentheses in there. There we go. Now let's add transform dot position equals new vector 3 and head pose X 1.0f and negative 10, 1.0 and negative 10.0f. Now, in the previous example, I said hand icon.transform, and that's because I was applying the transform to an object in the scene. If you don't provide an object for it to transform upon, then it's going to act upon whatever the script is on. In this case, that's what we want. We're changing the camera perspective, and the script is on the camera, so that's why this is written that way. So let's go ahead and save, and then look at it in the scene. So now if we hit play, you'll see that the camera is going to track where my head is leaning. So that summarizes some basic functionality of the Perceptual Computing SDK as it's used in Unity. A more complex example is another project that I made. I'm going to pause while it loads, which is this Asteroids game. So if we play, instead of casting what it's seeing, it's showing an overhead map of the ships coming at us, and when I lean, then it comes in a variety of steps, and when I open my hands, it goes on auto fire to destroy these guys. And they all have different score values attached to them. So yeah, some fun stuff you can make.